Hello, my fellow Java code geeks. My name is Andy, and today I'm going to teach you how to write clean, efficient Java code using interfaces. We're going to learn about what is an interface. We're going to learn about why we use an interface. We're going to talk a little bit about some new features added in JDK8 to interfaces. And finally, we're going to finish up with an example. Now, complementary to this video tutorial, you can find related articles and resources in the description below. Of course, you may visit Java Code Geeks and stay up to date with everything Java related. Just before we continue, if you guys like these guides and videos, take a minute to subscribe, like, and don't forget to hit that notification bell, just so you know when our next video is up. So, without further ado, let's get started. So we're going to start by talking about what is an interface. Now, an interface is a collection of abstract methods. That's it. Now, we know from object-oriented programming that in a parent, if we create abstract methods, all the children have access to those methods, but they have to override them and actually write the code. Now, when a class uses an interface, we don't extend it like normal object-oriented programming. Instead, we implement the interface. More on that when we get to our example. And an interface contains, as I mentioned, abstract methods. It can also contain constant variables, default methods, static methods, and of course the abstract method bodies. No code, just the declarations. Now there are some similarities and differences to a class. Some of the similarities include, well, interface can have any number of methods and it's stored in a .java file. The differences, well, you can't instantiate an interface, therefore there's no constructor. All the methods have to be abstract. There are a couple of exceptions, and that's some new features added in JDK8, more on that later. And attributes are static and final. Why do they have to be static and final? Well, you can't instantiate an interface. Therefore, there are no instances of it. Doesn't make sense to have instance variables. So why would we use an interface? Now, when we get to the example, this will become a little more clear. I'm just going to go through some quick high-level reasons why we'd use an interface. It forces a class to adhere to a certain API. Because it has abstract methods, when a class implements an interface, it has to use all of those methods. So it's a common way of interacting with a certain class. You can't have multiple inheritance in Java. Whenever you use object-oriented programming, a parent class can have multiple child classes, but a child class can only have one parent class. This is a way for you to actually have one parent class, but then you can implement multiple interfaces and have access to multiple abstract methods that you can then use and put forward so other classes can interact with you in a common way. It also decouples the what from the how. The abstract methods are what the class can do when it implements the interface. The how is how the class actually implements those methods. In other words, what code is each class going to be writing inside those methods to do what it's supposed to do. Remember, each class can do whatever it wants to do inside of those methods. It may do it differently than another class. The point of the interface is to have a common front, a common way of interacting with the class. So what are some of the new features added in JDK8? Well, there's a couple. One, static methods. Interfaces can now have static methods, and of course, a static method on an interface allows you to access that method and run its functionality without actually instantiating a copy of it, which you can't do anyway with an interface. It's very similar to a static method on a class. The other thing is you can have default methods. As you know, whenever you're using object-oriented programming and inheritance, if you have abstract methods, if you add an abstract method to a parent class, all the children won't compile anymore because they have to implement, they have to override that abstract method before you can even compile your code. Well, JDK8 now allows for default methods. So in an interface, you can actually add new methods without affecting the classes that implement them, without making it uncompilable. Time for an example. But before we head over to NetBeans, let's just quickly outline our example. So here I've kind of put everything out on the table. We have a city. Inside that city, we're going to have a person. We're going to have a house. Inside the house, there's going to be a CD player. And there's going to be an inheritance tree. We're going to have a bunch of vehicles. Now, we can have motor vehicles. We'll have a couple of different cars, an expensive car and a cheap car, and we'll have a bicycle. Now, you can see underneath the expensive car and the CD player, I have in blue some text that says that those are going to be music players. In other words, the expensive car, well, it's so expensive, it has a radio. So there's something that will play music. The CD player is also something that plays music. Now, they play things a lot differently. The expensive car has a radio. So that's going to be playing classic rock. It's going to be playing classical, depending upon whatever station you set it to. The CD player, however, will not have that. The CD player will be playing music from actual CDs that you have to put in. So those are two completely different ways of playing music, but we're going to want the same interface, the same API to interface with the music player to turn it on, to change the volume, and so on. So this is our example. Now let's head over to NetBeans. So here we are in NetBeans, and it's going to take a little while to get up to the point where we're ready to do an interface. In the meantime, just bear with me and let's get through all of the preliminary work to set up that scenario that we talked about a moment ago. So first things first, we're going to create, well, we have a project called Learning Java Interfaces. We're going to create a Java class. First class is going to be called City. This is going to be our the main class where we actually have our main method. So public class City. What are we going to have in here? So for now, all we're going to do is we're going to create our main method. Okay, we're not going to put any code in here just yet. We're just going to create all the base classes for now. All right, so that takes care of City. And now what we want to do is we're going to create the two classes, one for the house and one for the person. All right, so now let's create our inheritance tree. So the inheritance starts with a vehicle at the top. So create one of those. Now, of course, vehicle is abstract. We can't instantiate a vehicle. We can instantiate a specific kind of vehicle, but not a vehicle generically. We're going to also create our motor vehicle. Of course, that's also abstract. Whoop. It would help if I could spell. There we go. Much better, much better. Okay, let's create our non-motor vehicle. And of course, now we can create our three actual classes, not the abstract classes. We'll create the expensive car, the cheap car, which are both motor vehicles, and then a bicycle. All right, so now we have our basic structure set up. So what are we actually going to be doing? So let's actually start with the city class. So the city class is our main class. That's where we're going to be instantiating everything, running our simulation, basically testing. So the first thing we're going to do in city is we're going to have an array of people, and we're going to have an array of vehicles. So let's do that. Private. All right, there are our arrays. Great. So in city, in main, now, in order to create this simulation properly, we don't really want to deal with this static. So what we have to do is we have to actually create an instance of the class city. So we're going to create a variable city C. We're just going to say it's equal to a new city. And then we're just going to call c.start. And we're going to write that method now. So let's write this method. Private void start, and this is where we're going to put all of our test code. Okay, great. So now in here, what are we going to do? We're going to instantiate, we're going to create our arrays and instantiate a couple of objects. So first we're going to do people, equals new person. We're going to create 2 people, and let's create them. And you know what? I actually think that we need to pass in a parameter here. We're going to pass in the name of the person. Let's create Mary, and I'm going to copy and paste this code. We'll create another one called, we'll go with Fred. Okay, now obviously these are in red because the constructor for person doesn't have, well, we don't have a constructor. We only have the default constructor. So let's create one. And what we're going to do is create an instance variable, private name. And we will just set that variable equal to what we pass in the constructor. So now we have our person. Okay, great. So let's go back into city. We should be able to get rid of those red marks. Okay, good. Now let's actually create a couple of vehicles. So vehicle equals new vehicle, and we'll make 3 of them. All right. Vehicle. Oh, it's plural. Sorry. Okay, there we go. All right. Let's create all 3. We'll make the 0 vehicle equal to the that'll be the expensive car. This one will be the, we'll make this one the cheap car. And then we'll make vehicles to the bicycle. All right, there we go. So now we have our city pretty much done. Now we do want to be able to print out a status. Like we want to be able to print out who we have and what vehicles we have. And also like whether the cars are running, whether there are people in the car, stuff like that. We'll get to that later. But we do want to have the ability to print out all of the people and all of the vehicles. So we're going to call a method here called print state, the state of this simulation. And then we're going to actually have to write that method. So let's write that method over here. Okay, now in this method, all we're going to do is we're just going to loop through all the people and all the vehicles and print them. All right, and there we go. That takes care of our main method for the city. So now what we're going to do is we're going to go into, let's go into each one of these. We'll start with the person. And inside the person, we're going to write some code in here. So we already wrote the code that deals with the name. Maybe we should write some code. A person can have a location, right? So let's create a private string. We'll call it location. And in the constructor, we'll say that the location is, we'll start everyone at home. There we go. Okay, so now when we print an object of type person, Java prints just the memory address. So we're going to use the toString method, public string toString. And when you create this method, whenever you print an object of type person, Java is actually going to look for this method, and if it doesn't find it, it'll just print the memory location or the pointer to the object. But if it finds it, it'll call it, and then you can actually control what Java prints. So in this case, we're going to print, how are we going to print a person? Well, let's first declare a string, return string, and we're going to set that equal to the name of the person plus a colon, so we'll always know who's talking. And then let's concatenate that with the, how about the location of the person? So location, and then inside parentheses, we'll actually print the location of the person. There we go. And then, of course, the way the toString method works is you don't actually print what you want to print, you just return what you want to print. And Java will automatically use that value, whatever you return, to actually print the person. So let's do the same thing for, I think we want to do the same thing for vehicle. So here we are inside the vehicle class now, and the first thing we need is, I think we're going to need a name for the vehicle. Now, obviously you don't give your cars names, but maybe some people do, so let's do that. So we'll create a protected variable. It'll be a string, and we'll call it name. Okay, and let's have another one for location. All right, And now what we want to do is we want to have a constructor. So let's create the constructor. Now in the constructor, we're going to want to set the location equal to home. All vehicles, everything is going to start at home, but we're going to want to set the name. Now, how do we force the child objects to create an actual name for the vehicle? Obviously, vehicle is a generic object, so we're not going to have a name for this. We're going to have a name for the expensive car, we'll have a name for the cheap car, and we'll have a name for the bicycle. So how do we force that? Well, we force that with an abstract method. So let's create an abstract method, set name, and that's going to force all of these children to create this method and set the actual name. So let's actually call set name. By creating the abstract method, we're allowed to call this in the vehicle class, and we're guaranteed that all the children, expensive car, cheap car, and bicycle, will all create this method, overriding it, and actually setting the name to some value. And we'll get to that in a minute. Now let's do our toString method. String to string. And don't forget, this is going to return the value that we want Java to print. So for now, we're going to say return string is going to be equal to name. We'll do the same thing, plus, and then a colon, so we know who is being printed. And then return string plus equal. We'll do the same thing. Space, location in parentheses, and then inside the parentheses, we're going to print the actual location of the car or bicycle, whatever it is. And of course, we need to return that. All right, there we go. All right, so that should take care of the toString. That should take care of the constructor. Now what we're going to do is we're going to move over to the motor vehicle. Well, actually, I don't think we need to do anything on the motor vehicle, but what we do need to do is we need to move over now to, when we save, you'll see. So now when we save, you can see that all of these child classes are not going to compile. That's because we need to override the abstract method. So let's do that right now. So if we go to the expensive car, let's go there. And as you can see, well, it's in red. So the first thing we're going to need is we're going to need, well, let's override. And we'll call this protected void, whoops, misspelling, set name. Okay, that's the abstract method. And we're just going to set the name equal to, what are we going to call our expensive car? Let's think of a good, we'll call it My Sweet Ride. There we go. Okay, that's great. Now, that's perfect. Now I'm just going to copy this code. If I go to cheap car, I have to override it as well. Now, just so you know, there is a quick way in NetBeans. If I click on this, I could say implement all abstract methods, and you can see it puts it here for me. But I already copy and pasted the one from expensive car, so I'm going to just use that here. Now, for the cheap car, well, we're not going to call it My Cheap Ride. We're going to call it, let's see, what is it cheap? We'll call it My Clunker. All right. And then, of course, for bicycle, we're going to have to do, what can we call bicycle? Let's see. We'll just, I think maybe what we'll do is, we'll just call it My Bicycle. No point in getting fancy here. My bicycle. There we go. Okay. So now, just a quick test. This is always a good idea to test your code as you move along. So let's run this and see what we get. So as you can see, we're printing our state. Now it's using the toString that we created in person and in vehicle. And you can see it prints Mary, the location is home, Fred is home, My Sweet Ride, that's the expensive car, My Clunker, that's the cheap car, and My Bicycle. So far everything is looking good. Okay, so now that our setup structure is complete and we have the ability to test it and instantiate the objects, now we're going to turn our attention into allowing a person to actually enter and exit a vehicle. Now, we're not going to worry about the same person being in multiple vehicles. We're not making a comprehensive, robust simulation. We just want to get the idea, just get the basic structure down so we can talk more about interfaces and how we use them. So let's add some code to allow a person to enter a vehicle. So here we go. In the vehicle class, we're going to come here. And what we're going to do is we're going to create a variable here called, well, it's going to be protected. And it's going to be driver. So person, type person, and it's going to be called driver. All right. And now what we're going to do is we're going to head down to our constructor. Let me actually close this so we have a little more room. And in our constructor, initially, when a vehicle is created, the driver is null, right? There's no driver, okay? Now in our toString method, okay, we added the location. Let's add the driver to what's printed. So it'll say my sweet ride, location home, and then it'll tell us who the driver is. So we will do, let's see, if driver, if there's a driver, then what we're going to do is we're going to say return string plus equals, and what are we going to print? Well, space driver, and then in parentheses, we're going to add the name of the driver. So how do we get the name of the driver? Well, driver.getName. Of course, that's going to show up in red because we haven't coded that yet. So we'll get there in a minute. Actually, we might as well go there now. So let's go to person. The driver is a type person. So let's create the method getName. There we go. And that should take care of this error. Yep. Okay, perfect. And now in the vehicle, we're going to want the ability to enter, have a person enter the vehicle, and we're going to want the ability to have the person exit the vehicle. So first things first, let's create our enter method. Okay, so we're going to pass in the person that's going to be entering the vehicle. And what are we going to do in here? Well, the first thing we have to do is make sure there isn't already a driver inside the vehicle, right? Only one driver per car, one driver per customer. So if driver not equal null, then what we're going to do is we're just going to print something. We're not going to really do anything else. We're going to print the name of the vehicle so we know who's talking, and then colon, and then we're going to say enter failed. And then we're going to say, I already have a driver. All right. Otherwise, if there isn't a driver, we're going to set the driver equal to the person that we pass in. And then we're going to print, just do a little narration, again, name with the colon. And we're going to say, oh, we have to print the person's name. So let's do driver.getName, our new method is now my driver. All right, perfect. Let's also make an exit method. So it's going to probably be very similar to this. So let's just copy and paste the code. We'll call this one exit. Of course, we don't need to pass in who's exiting because we already know who the driver is. So first thing we're going to say if the driver, this time we're going to check to see if there is no driver. We're going to say exit failed, and we're going to say I don't have a driver, right? So there's nobody that can exit. And then the else is when it works, so we're going to set the driver to null, meaning there's no driver. And now let's change our message. So we're going to say, I no longer have a driver. Okay, so that takes care of the vehicle. So now let's head over to the city class, and we will add some test code that we can use to make sure that we can enter things properly. So let's add, let's say vehicles one.enter, and who's going to enter? People 0. I think that's Mary. All right. And then let's do another one. Vehicles one.enter. Let's let Fred try and come in there. That should give us an error because Mary should be already in that car. And then let's do vehicles 2. That's our bicycle.enter. Fred will get on the bicycle. So let's do that. And then let's just try that. So let's run. And when you run, you can see, let's see, my clunker. Mary is now my driver. That's correct, right? Number one is the clunker. My clunker, enter failed. Fred cannot enter that car, right? Because we already have a driver. But Fred can now be on the bicycle. And now, as you can see, when we print, Mary is home, Fred is home. The expensive car, fine. Clunker, oh, clunker has a driver, Mary, and Fred is on the bicycle. All right, now let's test the exit method. So let's do vehicles of 1.exit, and let's do vehicles 0.exit. Now that one should give us an error because we don't have a person driving the expensive car. So let's run this, make sure everything works. My clunker, yep, okay, Fred exited. That's perfect. We can't exit the bicycle because we don't have anyone on the bicycle. And now when we print the state, you can see that clunker does not have a driver. I'm sorry, that was Mary, not Fred, my mistake. But the bicycle still has Fred on the bicycle because we didn't exit. We didn't exit from vehicle 2. All right, so that is perfect. Now what we're going to do is we're going to head over and we're going to allow functionality for the vehicles to start and stop. So let's head over to the vehicle class right here, and we're going to add a couple of variables. Let me close this. We can work a little better. All right, so we want to start and stop our vehicle. So the first thing we need is we need a variable. So let's create one. Protected. It'll be a Boolean, and it'll just keep track of whether or not the engine has been started. And we're going to have to default that. So when we create a vehicle, it's going to be obviously off. So now we need to be able to actually start and stop it, which means we need methods for those. But we're going to have a different start and stop method for our motor vehicles versus our non-motor vehicles. So what we're going to do is we're actually going to create an abstract method, actually 2, in the vehicle class. That way, when we create our subclasses, our children, we'll force them to create the start and stop method. So let's do that. We'll create a protected abstract void method, and it'll be called start. And we'll create another one called stop. There we go. Okay. So now when I save, as you can see, my actual classes that are not abstract won't compile anymore. But the same start method and the same stop method are going to be used for both of the cars. So really, I could write those methods in my motor vehicle class. So let me do that. So I'm going to go over to the motor vehicle class now, and we're actually going to create, we're going to override. And what's going to happen inside the start method? Well, first we're going to check to see if the engine was already started. And we're going to print the message. And what else? Well, if there's no driver in the vehicle, we certainly can't start the engine, right? That would be a bad thing. And I think those are the only 2 conditions. So we can go ahead and start the engine. And there we go. Now let's do a stop method. Let's see. Let's just copy and paste this because it's going to be pretty much the same. Whoops. There we go. We'll call this stop. And now what we want to check to see is if the engine is not running, then stop failed. My engine is already off. We don't have to worry about checking to see if we have a driver because there's no way that the engine would be started if there's no driver in there. So let's just go with an else statement. And the else statement would be, all right, let's change this to false. And then we can say my engine is now off. All right, perfect, perfect. So now let's head over to the non-motor vehicle. Now, before we do that, when I save this, take a look at these 2 classes. These are the actual classes, not the abstract ones, but because we overrode those abstract methods and coded them inside motor vehicle, When we save this, you can see those compile errors go away now. We no longer have to override them here because we're overriding them in the parent class both. Of course, we have to do the same thing for bicycle. So let's override that here. And bicycles, any non-motor vehicle can't start, can't stop. There's no engine, right? So all we're going to do is we're just going to print a message. And we're probably going to do the same thing for stop. So let's just copy this. And there we go. Now the only thing left to do is go into our city class. And let's make some test code. So we have, let's see, we have our vehicles created. Let's see. First thing we're going to do is, well, let's get rid of this. We don't need to test that stuff anymore. What we do want to do is, we do need to start a vehicle. So let's try and start one. Now that should fail because there's no driver in vehicle 0, which is the expensive car. So let's try it for vehicle 1, which is the cheap car. And let's actually put a person in there first. There we go. And let's try and start vehicle 2. All right, and is there anything else we need to test? I don't think so. Oh, we should probably test stopping the engine, right? We should definitely test stopping the engine. But before we do, let's just test this. Let's run here. Here we go. Let's see what we got. So vehicle 0, which is the expensive car, it failed, doesn't have a driver. Vehicle 1, clunker. Mary's now driving it, correct. And then my engine is now running, correct. And we can't start the bicycle because the bicycle doesn't have a motor to start. All right, perfect. However, when we're printing the vehicles, I think what we're going to want to do is we're going to want to say whether or not the car is running or not, or the vehicle is running or not. So we should go to vehicle. And we should go into our toString method. And over here, we should say if engine running. What did I do? Did I misspell that? Engine running. Oh, engine started. That's why. There we go. Okay. So if the vehicle is started, then we're going to just write run. So let's test again. And when we print our status, our state, you could see right here, the clunker is running. All right, perfect. Now let's test stopping the vehicle. So we printed our state. Let's go back to city. We printed our state. Okay, we know that this works. So now let's actually stop vehicle 1. And let's try it twice. The first time it should work. Second time it should give us an error. Actually, let's do 0. So this one should work because it was started and it should be able to stop. This one should fail because it was never started because nobody was actually in it. So let's run this, see how it goes. All right, so we don't have a driver. We can't start it. We know this. We've already seen this. We've already seen this. Now we've turned the engine off right here. Perfect. And vehicle 0, we can't stop it because the engine's already off. And now when we print our state, you can see that this car is no longer running because we've stopped it. Okay, so now what we're going to do is we're going to allow a vehicle to be driven. So let's go back to our vehicle class. Let me give us some more room here to work. And we're going to create a method on the vehicle class called drive. So let's go over there, down at the bottom, and we will say, let's see, public void, and we'll call it drive. And what are we going to do in here? Well, the first thing we have to do is we have to check to see if we actually have a driver. And if we don't, we have to print a message. So let's print our normal message. Okay, else if. Now, what else can prevent us from driving? Well, the engine may be off. All right. Otherwise, it looks like we should be able to drive. So we're going to keep this real simple. We've already set up a location variable, and the location variable is all set to home. So let's just say we have a home and a store. So we'll just do something very simple. So if we are at home, if location dot equals home, then what we'll do is we'll say the location equals store. So we'll just basically flip-flop back and forth between the two. We'll just toggle back and forth. Otherwise, if we are at the store, then we're just going to go home. Okay, great. So now let's just narrate something. So we'll print the name, print colon, and we will say, I have been driven to, and we'll print the location. Perfect. Okay. Now, one other thing, if there is a driver in the car, which there should be if we get here, we need to tell that person that you're now in a new location as well. So driver dot change location, and we'll pass in the new location. Obviously, that's in red because we haven't coded that yet. So let's head over to person, and we will code that right now. Where are we? Person. Okay. Public void change location. We're going to pass in a new location. And what we're going to do is we are going to set the location variable to what we pass in. All right. So that should take care of that error in vehicle, and it does. As you can see, it went away. Perfect. All right, and now let's see, what else do we need to do? I think there's another problem because we're not going to be able to drive the bicycle anywhere because the bicycle, remember when we create a vehicle, the engine started is false, but when we're trying to drive, we're checking to make sure that the engine has been started. So I think with a bicycle or any non-motor vehicle, what we need to do is we really need a constructor here. So let's create a constructor. And I mistyped the O. And what we need to do is, even though we can't start or stop an engine, we need to just set the variable. Now, I'm sure there are more efficient ways of doing this, more proper ways of doing this, but we're trying to keep this simple. We want to just get through the basic structure of this demo of the simulation, just so we can get to the interface and explain what the interfaces are going to do. So now that we have that, let's head over to our city class and write some test code. So let's see, let's get rid of this. Let's start out by putting somebody in the clunker. All right, and the next thing we're going to do is we're going to start the car. Okay, and then we're going to drive the car. All right, and the next thing we're going to do is we're going to put, I forgot the parentheses. The next thing we're going to do is we're going to do the same thing with vehicle, we're going to do the same thing with vehicle 2, which is the bicycle. We're going to put person number 1 in there. We don't have to start it, by the way, because that's a bicycle. We're just going to drive the bicycle. And last but not least, we're going to try and drive vehicle 0, which is the expensive car, without starting it. Let's see if all that works properly. Let's see. So Mary's the driver of the clunker. The engine's running. We are now at the store. Let's just double check. The clunker is at the store and Mary is at the store. Perfect. Okay. Now vehicle 1, Fred goes in there. We start the car. Vehicle 2. Fred goes on the bicycle and we drive the bicycle to the store. Let's double check. Bicycle. Fred is now my driver. Bicycle location is the store. And it does say running. We would have to fix that, but again, we're not going to worry too much about that. And as you can see, Fred's location is the store and the bicycle has been driven to the store. Last but not least, expensive car, we're trying to drive it. No good. We don't have a driver. Okay, and obviously even if we did have a driver, we would have to start the car as well. So now what we're going to do is we're actually going to start creating music from the CD player. Now, what most people would think is we could go to the CD player and create some methods that will allow us to, say, change the volume, play the music. But the issue with doing it in the CD player is, let's say we want to do it somewhere else as well. Like, for example, our expensive car is going to have a radio that we're going to allow somebody to play. So we want to make sure that it's consistent. We want to make sure that the interface for playing music is the same in the car as it is in the CD player, as it is in any other object that uses, that is allowed to play music. So we're going to use a Java interface for that. So the first thing we're going to do is create new Java interface. We're going to call it music player. So this will be a list of abstract methods that will be implemented in any class that has the ability to play music. So we'll say finish. Let me get rid of all these comments. Don't need them. Okay, so interface music player. Now, what API, what methods will some class need that needs to play music? Well, there's a whole bunch. We're just going to pick two. Let's go with public void change volume. Okay, and we'll pass in new volume. Okay, now notice I put a semicolon here. This needs, because I don't have to put the word abstract like this. This method is automatically abstract. Why? It's in an interface, so I don't need this keyword here. Next method, play. So these are the two things that you can always do with a music player. Now let's head over to our CD player. So we want the CD player to implement music player. Would help if I spell it properly. There we go. Okay. So CD player implements music player. Now look, you notice this is underlined in red. That's because there are abstract methods that have not been created here. So we need to create those abstract methods. So in NetBeans, you can just click on this and say implement abstract methods. They all get put down here, by the way. But you have to get rid of this code, and you have to actually you have to put code to actually change the volume. Now, it's going to be different. Changing the volume and playing music is going to be different on a radio than it is a CD player. The radio would be in the car. So for the CD player and the radio, we're going to be able to create our own methods to do whatever we need to do, but anybody using this device will know that they can always call change volume and play. It's a common API. So change volume, what we're going to do is we're going to say volume equals whatever was passed in. Of course, we need a variable on the CD player to keep track of the volume. And let's default that to 0. Okay, and now playing music, again, playing music on a CD player is going to be a lot different than playing it on a radio. It's also going to be a lot different than playing it on, say, an electric guitar with an amplifier, where you can also change the volume and you can also play the music. So here, the only thing we're going to do here is just print CD player, I am playing my music, and let's also list the volume. Okay, there we go. All right, so that takes care of the CD player. Now, obviously, if we were building a CD player, play would be a whole bunch of code that does different things for CD player than it would for a record player and so on. But here, we're just going to print something just to illustrate the point. Now, let's head over to house. Okay, so in house, we're going to need a method that we're going to pass through to our CD player. It's going to be called change volume. And we're going to pass in the new volume. And all we're going to do is pass it through. Okay. And of course, we also need a play. And we'll pass that through as well. All right, so now what we're going to do is we're going to head over to our car. Now, don't forget the car has a radio. So this expensive car, now look, it has a parent class, motor vehicle, but we can also implement the music player. That means that this car, it has a radio, will get the common API that all other music players have. So let's override, I'm sorry, not override. Let's implement the abstract methods. Okay, now because there's a radio in here, we are going to need a variable for the volume. Okay, and let's see, let's create a constructor and default the volume. Okay, there we go. Now, we need to override these methods. Changing the volume on a radio is basically the same thing as changing the volume on a CD player. So we're just going to do volume equals our new volume, no difference there. But now playing the radio, would be a lot different than playing a CD on a CD player. Of course, here all we're going to do is print something. Notice here we have a name, the name of the car, right? That's a difference right there. And we're just going to say, I am playing my radio. And let's also print the volume. Okay, and there we go. Now let's head over to our CD class and test. So we've turned on our CD player. Let's say house.change volume. We'll make it 4 and house.play CD. Okay, now we can tell our expensive car to turn on its radio and change its volume. Change the volume and play. So what's the expensive car? Vehicles 0. So we're going to do vehicles 0 dot change volume 5. Okay. And now you notice this is underlined in red, and that's because there is no change volume method on vehicles. Vehicles does not implement the music player. The motor vehicle does not implement the music player. The expensive car does. The cheap car does not. So this expensive car is the thing that's implementing music player. The expensive car class is the thing that gets these methods. Therefore, we need to cast this variable into an expensive car. Notice vehicles, the array is type vehicle. It's not type expensive car. This is called polymorphism. That's the subject of another video. So we're going to have to cast this variable into an expensive car. Just like that. And now we can call the method change volume. Of course, we can also copy and paste this and call the method play. No parameter. All right, let's test this, see how it works. Here we go. And the CD player in the house is on. We're playing the music, volume 4. My Sweet Ride. We're playing our radio, volume 5. And here's the state of everything. And that is how you create a Java interface. And that is an example of when you would need it. Well, I hope you enjoyed this video. If you did, be sure to smush that like button and subscribe to the channel. We've got some really cool stuff coming up. Bye.